Yeah.
Okay. So first we'd have to understand that we're going to have a metal atom. It's going to be neutral. It's going to be monoatomic. All of our metals except for mercury, that sneaky mercury, always exist as just the metal, a solid with zero charge. That's, and I don't have to be in the picture.
Oh, okay.
Although I have my cute red hair now. A metal atom is neutral. It's going to be a solid at room temperature, and it's monoatomic. There's only going to be an invisible one here. So that's all we have. And it's going to either gain or lose electrons, and we'll figure out which one in a second, to make a metal ion. What charge do we always have on our metals? Are they positive or negative? Yeah, those metals, they're like the little kids on the playground, always giving up their lunch money to the boys. They always give up electrons, so they always have a positive charge. They have more protons than electrons. So we're going to have our metal atom lose electrons and become M plus something. And now will it still be a solid if it's an ion? It becomes, we're going to pretend this is happening, let's say, in water. So this is going to be aqueous now. Our ions will be aqueous, they'll have a charge. Our solids will be neutral and staying still monoatomic in both places. The reverse is going to happen for the other species in the reaction. There's going to be a metal ion, somebody who's got a positive charge. And he's going to be probably part of a formula or a compound. So you would have something like a metal and then some sort of anion. It's going to go and do the opposite. The electrons that are lost from the metal atom, it's going to gain the same electrons that the metal atom lost. Then it will become itself a metal atom. It will be neutral. It will still be monoatomic. And it will become a solid. We'll be able to see them. I can't see invisible ions. If you can, let me know. We'll get you in the Guinness Book of World Records. For me, I can only see when we start having our neutral atoms and they start collecting and making a pile that I can finally see my solid metal. So in this problem, back over here, where we had the 4 grams of tin metal, does it matter that we have 4 grams, or is that just there to kind of throw us off? Do we need that to write half reactions like this, that something loses electrons, something else gains electrons? How much you have makes no difference. What does matter is that it's solid tin metal. So is that going to be the guy up here, the metal atom, or is that going to be the metal ion?
The metal atom.
The metal atom. He's solid. And one way I remember that tin is SN, as I kind of think of snotten. So SN is going to be our metal atom. He's going to be a solid. And what's his charge going to be?
None.
None. Good. He's neutral. He's 0. I wouldn't see him if he was an ion. He'd be invisible. So then, he's supposed to react with chromium-2 acetate. Well, let's see what chromium-2 acetate would be. What's the symbol for chromium? Cr. And I'm going to be honest with you. I know what the formula for acetate is. You should know it because we're doing acid-base chemistry. But honestly, it's not so important what the exact formula is as long as we have the information about the charge on it. So I'm just going to put acetate because what I care about is that 2. For my half reactions, the ion, the anion here, is not really important. What's he called? The ion that's not going to be participating in the reaction?
Observer.
Spectator.
Close. The spectator. He's the spectator at the game. He's going to sit and watch all the action, eat some popcorn, and stay in solution the whole time. He's not going to be doing anything. So the spectator ion is going to be our acetate ion. And in case you wanted to know, that's CH3CO2 minus. But what I really care about is the fact that I was told the charge on the chromium. So now that chromium 2 plus, is he the metal atom or the metal ion?
Ion.
He's the metal ion. He has a charge. He's going to be aqueous. So let's give it a shot. Over here, I'll do it right here. We'll have our metal. And we'll have our chromium. These are going to become our two half reactions. Our metal atom is going to lose electrons. Where should I put electrons if they're being lost? Do I put them on the reactant side, where I put plus electrons? Or do I put them on the product side over here? Product side, good. And we're going to figure out how many electrons we need to lose based on the information from here. So if you'll go back over to this part with use the name of the ionic compound to determine the charge on the metal ion. The ionic compound told us that our metals have a chromium 2 plus charge. Step 2, add the same number of electrons as the charge number on the metal ion. So how many electrons should I add to chromium 2 plus? 2. This is the charge number, so I'm going to add 2 electrons. Good. What's that going to form if I have 2 plus plus 2 minus? Neutral, big fat 0. All right. So this is our neutral monatomic atom. Up here, we have our neutral monoatomic atom. And guess what? He's got to get those 2 electrons from somewhere. Who's he going to get them from? The tin, that's right. The tin up here that lost electrons. How many electrons do we now know he's going to lose?
2.
2. It's the same 2 electrons. If he needs 2 electrons, tin is the place he's going to get them. So in step 3, we remove the same number of electrons from our metal atom that's equal to the charge on our ion, basically. We want to make sure it's the same 2 electrons. And all we have left to do now for step 4, we need to write our charge on our new ion. It's got to equal the number of electrons it lost. So what's going to be our charge? We lost 2 electrons, and now will he have a plus charge or a minus charge? We lost 2 electrons. Plus, good. Means he has 2 more protons than electrons. This is the answer to letter A. These are my 2 half reactions for oxidation reduction reactions. Letter B, label which one's oxidized, which species is oxidized, and which is reduced. You have only 2 choices. It's going to be just the reactants. So was it the tin that was oxidized, or was it the chromium 2 plus? And if you don't quite remember, my favorite is Leo says grr, because I imagine this cute little line going grr. If you lose electrons, you're oxidized. If you gain electrons, you're reduced. Some other people remember it as oil rig. You're oxidized if you lose electrons, you're reduced if you gain. Come up with your own trick to remember that balance, and you'll be all set. I'm going to stick with Leo says Burr because this just keeps reminding me of the Gulf spill. So tell me, who was oxidized? Who lost electrons? Tin lost electrons. And we could just leave it as tin. And who was reduced? Chromium. Now we got to be specific, not just chromium, but chromium plus 2. That's right. The chromium ion was reduced. He gained 2 electrons. That was not supposed to be a plug for Cherry Coke Zero. Sorry.
For American Idol.
I'm not getting paid for doing this. I have no sponsors. Letter C. We're supposed to identify the oxidizing and reducing agent. What's the job of a real estate agent?
Sell a house.
Sell a house, sell property, sell real estate, yeah? So if you want to think about it, the job of the oxidizing agent is to oxidize somebody. And so, who got oxidized?
Tin.
The tin. Well, who did the job of oxidizing him?
Chromium.
Chromium 2 plus, the only other guy that was there. And now, meanwhile, tin had a job to do. His job was to give the electrons that would reduce the chromium 2 plus. That's not right. Reducing agent. That's what happens when I talk and write at the same time. All right. And our reducing agent, therefore, must be
Tin.
who?
Tin.
Tin. The tin. Our neutral tin atoms. It's opposite. If you're oxidized, you're the reducing agent. If you're reduced, you're the oxidizing agent. Are there questions? Yes. Okay, for my students using our textbook, I believe it's page 149. This is similar to that. This is one I made up myself. But it's the concept of oxidation reduction reactions. Yes? Yes. There are 2 parts. We have 2 half reactions. And together, you would say that tin plus chromium 2 plus forms tin 2 plus chromium would be the whole reaction. So we're just looking at the half reactions to see what's going on. Okay, I think that's it.
Hit the red button.
Hit the red button.